A lot of work time. Quiz tomorrow, and so hopefully Lucas is listening to this and ready to go. Nothing new today, really, for this, but other than obviously talk about this with angular linear velocity. So first part of the period again tomorrow, we'll do the quiz. You have plenty of time before lunch. Have a problem, kind of an assignment that involves a bike scenario for you to work on after you get done with the quiz. And then we'll pick up on some new stuff a little bit after lunch in a short assignment for Monday. Okay, so that's the plan tomorrow. Today we got a couple of worksheets we'll work on one in class here, focusing on the angular and linear velocity stuff. That's kind of our focus, okay? Didn't have very many people in this morning, so that, I don't know, maybe a good sign. Maybe everybody will be here tomorrow morning. Maybe you'll wait till the day of the quiz kind of people, I don't know. But we should have plenty of time to do some work here in class, hopefully, and have a chance to ask questions and so forth, okay? So converting radians to degrees, so that's where we multiply by pi over 180 if we're converting to radians, right? Because the degrees are on the bottom, so they would cancel out, so you'd end up with radians. Or multiply by 180 over pi, that's the one, usually with decimal radians you would use, but the pi's on the bottom, that's your radians, so radians would cancel out, end up with degrees. Or a lot of times we just sub pi out and put a 180 in its place, right? So if I have 2 pi thirds, I want to do that into degrees, just put a 180 in for pi. And just sub it in. So whatever, that's our radian to degree conversion. So there'll be some of that. DMS just on your calculator, right? Degree minutes, seconds, type it in. So just do a couple of those just for practice. But that'll be a small part, couple points probably out of the 30 or whatever's on the quiz. Be able to determine what quadrant angle's in. Do some coterminal, one positive, one negative, or something like that. Both in radian and in degrees. Okay. So, and again, you don't get to use this on the quiz, but if you want to look this over, right, where we have degrees and radians, on your circles here, that kind of thing, understanding those values, and the decimals on the other side, just kind of be comfortable with that, is really all you're going to use on the quiz, a calculator, and that's essentially it. So have this other stuff understood, and then of course the angular and linear velocity, and that those questions probably half the quiz points maybe on angular and linear velocity, roughly. I don't know. So let's take a look at a couple. So I threw up some formulas up there yesterday, and the more people ask me questions and we talk about this, it comes to mind that maybe these are really the two biggies. These are really the two big formulas to know. I mean, angular velocity you pretty much get angular velocity just with revolutions. I mean, a lot of the problems will talk about RPM, so revolutions. Well, every revolution is 2 pi radians. So I'm not even sure you need to put that into the, if they say it's 30 revolutions per minute, I'm not even sure you really need to just go 30 revolutions. I mean, this is what I was doing yesterday, 30 revolutions per 1 minute, but it's 2 pi radians for 1 revolution, and I was doing this, and I'm not so sure, and that's fine, you could do that, but to be honest, it's almost just about as easy. If they tell you 30 revolutions per minute, just think, well, okay, every revolution is 2 pi, so it's 30 times 2 pi. I mean, so right away you can go 60 pi radians per 1 minute, and you're already at angular velocity. I mean, that's it. That's angular velocity. It's not really a formula. It's just your radians over time. Radians over time. Now, it could be degrees over time, but it's radians over time, most problems. So that's your angular velocity. And then the other main question we ask, now there's some other ones, like how many revolutions was there? So there's some other questions. But the main question then, if you've got angular velocity, is what's the linear velocity? Well, all you do is take the angular velocity times the radius. That's it, right? And so they give you so now you got the angular velocity, and then they say the radius is 6 inches. You just multiply that by 6, and there you go. Now you got inches per minute, and that's the linear velocity. So really, And then this one can be helpful for arc length. Now, Jack and I were talking this morning about arc length. So a lot of times you think of an arc, you just think it's part of a circle. Arc could be the whole circle. Arc could be 4 times around the circle, right? I mean, so arc is just a distance on the circle. Now, sometimes that's part of the circle. Sometimes it's all the way around the circle. Sometimes arc length is multiple times around. So it's just the distance on a circle is S, okay? And the R is the radius and theta is the radian measure of the angle, okay? All right, so, and then like I said, one revolution is always 360 degrees. It's always 2 pi radians, but one revolution can also be circumference, and we were having this conversation also. It was talking about one of the linear speed, and it said, so let's go back to this example. Let's say you had something that was going around at 6 RPM. 6 revolutions per minute, and it wanted to know the linear speed, okay? The let's just say inches per minute or whatever. Well, so what Jack said is, well, the circumference is 2 pi r, so the circumference is 2 times pi times, what did I say the radius was? Did I say? I don't think I said. Okay, so let's say the radius is 4 inches, okay? So he just did 2 pi times 4, so he just got 8 pi. Well, that would be inches for how many times around? That'd be 1 time around, right? So Jack was just doing circumference, and that makes perfect sense, right? So this particular circle, this is doing 6 revolutions a minute. Well, if the circumference is 8 pi inches, you would take that times what? You would just take that times 6. You would take that times 6 revolutions per minute, and so you get 48 pi. What would the units be? Inches per minute, right? We skipped right past angular velocity. We didn't even talk about angular. We didn't need it, right? It wanted inches per minute, and so Jack said, well, it's 8 pi inches around because that's circumference, right? 2 pi r, that's just circumference. So that's 8 pi inches around, and it's going to do that 6 times every minute. So you just take 8 pi times 6, it's 48 pi inches per minute. So I'm not really going to be checking your work. I mean, I will. If you get it wrong, I'll look at your work and try to see where you went wrong, maybe some partial credit. But if you kind of come up with some way that's not a formula or something to get it, I mean, that makes perfect sense. Remember, when we started this, I said my preference is you just think your way through it. You know, kind of common sense. You don't get lost in all the formulas. But you do have the formulas there to help you. So that's why I wrote this down here. One revolution, because a lot of the problems are revolutions per minute, RPMs, right? So one revolution is this many radians. That's what you're looking for, angular velocity, then you'd use this. But one revolution is also a circumference. So that's inches or feet or whatever, circumference. So it's a circumference over time. Okay, so you could think of it that way too. So whatever works. So we'll see that as we go through some problems here. Okay, so questions on the worksheet. I mean, I've got some answers here that we could look at real quick. So, the coterminal and stuff, I've got answers here. I'll just leave it up here if you want to check that later. Okay, the coterminal, that kind of thing, the positive and negative stuff. 11, 105 degrees. Number 12, 180,000 degrees. Again, it's 500 rotations per minute, and every rotation is 360 degrees. So don't overthink those, right? That's where you can get lost in formulas. It's 500 rotations every minute, and each rotation is 360. So you just multiply those. 180,000 degrees it would go through in 1 minute. Okay? Number 13 is 269,640. You don't even need the 27 inches, right? Because it says how many degrees in 1 mile. Well, it told you it went around 749 times. Every time it goes around, it's doing 360 degrees. Okay? So 749 times 360. So it's easy sometimes to overthink those. All right. Angular velocity of this Ferris wheel. Okay? It takes 45 seconds to rotate 1 time. Okay? And they wanted it in radians per minute. Okay? So angular velocity, so what we say? We said angular velocity is just the radians per unit of time. So in this particular case, it says it's going to rotate once, so to me that'd be 2 pi radians. And you can just put 45 seconds if you want, and then we just convert that, because that's already angular velocity right there, radians per second, right? So anytime, again, I'll go back to this, 1 revolution is 2 pi radians. So if they talk about rotating once, that's 1 time around, that's 2 pi. That's 360 degrees. Now in this case, they wanted radians. So it's going to go 2 pi radians in 45 seconds. So that's 60 seconds in 1 minute. Okay? And so there we got our radians per minute right there. And so get your calculators out or just reduce. 15 goes in there 3 times, goes in there 4 times. So that's going to be 8 pi thirds radians per minute. Okay, I didn't really follow any formula there. It doesn't really fit any of these formulas. It's just knowing that angular velocity is a radian divided by a time. A radian divided by a time. So it takes 2 pi radians, that's 1 revolution, in 45 seconds. And then just get your units matched. Okay, 26. If you sat on the rim of the Ferris wheel, what would be your linear velocity? So this is what I was talking about. Why this is, to me, this is a key. If there's one formula you're going to remember, it'd be this one, right? Because once you got angular velocity, all you got to do is multiply by radius. Just make sure units match. And that's your linear. So it's just angular velocity times radius. Okay, so we can just take 8 pi thirds, and remember we said radians is just kind of this unit that just kind of disappears when needed. We just multiply by the radius. And what was the radius? 125. Okay, so when you multiply these, the radius just goes away. Okay, radius just goes, or radians just goes away. And so we get 1,000 pi over 3 feet per minute. Okay? Because it's just R times W. It's just R times W. So again, if there's one formula to memorize, it would be this one. Because this one is harder to put into, you can't really put that into this because you're not really canceling any units. Right? You're trying to go to feet per minute. You've got radians per minute, you just got to multiply by feet. So that's where it would be of value to know that relationship right there. Linear velocity, simply take your angular velocity, multiply by the radius. That's it. Okay? All right. And then the last one, now that's it to the nearest foot per minute, so I guess that'd be a decimal answer, right? So you would go ahead and use your pi button to get a decimal answer. Okay? I'm probably, well, might say that, so, probably leaving them in pi is okay, but just follow the directions. The Earth spins on its axis every 24 hours. See, so right there, as soon as you read that, 2 pi radians, I don't know if I even need it, but as soon as I read that, to me, there's my angular velocity right there, right? It spins around once in 24 hours. That's 2 pi radians in 24 hours. That's radians per hour. Now, maybe I don't even need it. But if the Earth's circumference is 24,800, okay, so here's where it's a little bit of a twist, so you got to think a little bit. Find the linear velocity of a person standing on the equator in miles per hour. Okay, so before we get into that circumference thing, okay, what do I need to do to go to linear velocity here? Because what do I have on the screen right now? Angular velocity. So what have we been saying? How do we go to linear velocity? Just multiply by the radius. All I have to do is multiply by the radius. Right? Now, the key is making sure I got the right units. Okay? But all I have to do is multiply by the radius. So I need the radius of the Earth. Oh, shoot. They didn't give me the radius of the Earth. They gave me what? Circumference. So what do I have to do? 2 pi r is equal to 24,800. Right? So I need to divide by 2 pi. So that'd be 12,400 over pi. So divide by 2, divide by pi. Okay. Now, a lot of times what I would do in a problem like this is I might just leave it like that, but maybe not. Maybe you would just do a decimal. So somebody tell me that decimal. And what was that in? That was in miles, wasn't it? This was in miles, so this is going to be miles. Okay, so what's 12,400 divided by the pi button?
3,000.
3,947 point, okay, and you put a bunch of decimals there, fine, but that's miles. Okay, so now what happens to my units here? I went ahead and put it on that thing, but what happened? What are the units now when I'm done? What happens to radians? They just go away, right? They just go away. We don't have to cancel radians. We can cancel radians, but it's this unitless thing that we use it when we need it, like to say radians per hour. It wouldn't make any sense to just say nothing per hour, so it's radians per hour. But when we multiply by miles, this becomes miles per hour. So it's 2 pi times that divided by 24. Now, I've got 1,033.33, so 1/3 probably miles per hour. Okay? But again, what was the important formula? Probably this one, right? Angular velocity is not really a formula, it's just degrees or radians over hours. So as soon as it said rotates once, right, as soon as you hear a revolution or something like that, every revolution is 2 pi. 2 pi radians, right? 360 degrees, 2 pi. Okay? So you just put your radians over how long it takes to revolve once, and you're there at angular velocity already. Okay? So if that's what you want, reduce it, you're done, get the right units. Linear velocity, all you got to do is multiply by the radians. Okay? All right, so let's do a couple of different problems here. So here's 4 different problems. So go ahead and try it. You can work them on your own a little bit, but check with a partner if you want. We're going to do a kind of a partner thing, or where you can kind of work together here in a little bit. Right now, let's see what we do. So I got 3 different questions here. And then this is this was in the 2013 Omaha World Herald about the world's largest Ferris wheel. And so what it said about this is it's 550 feet tall, but the wheel itself has a 520-foot diameter. Costs $550 million to make. There's 520-foot diameter, and if you're riding on it, it goes around once in 30 minutes. That wouldn't be fun.
Bro, I get hungry.
It would just take forever, right? I mean, but anyway, 1 revolution in 30 minutes, like 50 some stories, 55 stories tall. But anyway, so 1 revolution in 30 minutes, what would be, so if you're on it, what would be your radians per second, what would be your feet per second? So do that for the Ferris wheel, and then answer those 3 questions too. See if we can do those real quick here.
That would be about. Oh, crap.
Oh, I did number one.
We did very well. I thought it was, the big one. We did very well. Wait, what?
I just don't have a question.
No, like, how, what made yours right there? Oh, we had to do that 8%.
Oh, how do you hear me?
Am I right? Am I right? Am I right? No, dude. How do you overrate?
We don't have that information, I can't do it.
Charlie. My stomach's like literally grumbling.
Well,
I need food. Jeff. Did you do number one or did you do the first one? Because they're two different questions. Charlie, you got a knife? I want to cut out pieces. Okay. Jeff. Did you do number one or the first one you're doing first? First one? Yeah, I'm on number two. Well, I can't read. I literally. Oh, you're
Enough time? Everybody's gathered around Claire, so she can show you the way.
Oh, 625. So, okay. I agree.
Everybody cheats off Claire.
I have that. It's in a minute, so now I have. You just can't believe I stopped there. I have a butter each one.
Allie, you got them all? Allie, you got them all?
You got any of them? I got number one.
Yeah, me too.
That's all we got, is number one?
Yep. We got stuck on number two.
Well, skip it, go on to number three. Why number two? Alright, well, it sounds like you guys are
Having some good discussions, so I'll leave you alone for a while.
Okay, so that's.
Are we all done? Okay. Keep going.
You guys think
Radio.
Are you doing
Culver's chicken.
No.
What?
Okay, so you know what it's like, they have.
Which doesn't help me at all.
I
I have on to number three.
Oh, their cheese curds are super good.
Caleb, you wanna go to Culver's? This is a good conversation. Radius of each chicken nugget.
Of course it's
Over 30 minutes.
For point two. Just because you multiply by 6.
Trying to get them all done.
See what's in there? 18 meters. Is that
Jack, just do 18. That's over 2.
Do you think the radius?
I have some on 2.
260.
My other class. But.
Charlie. I need you, baby.
What did you get for reading?
Wait, But that was linear law. So where'd you get the S on that thing?
One of the formulas.
God's name. Get it.
V equals S over.
I didn't do that, so I did it. Yeah. Okay, I'll give you a repeat for a second.
I don't, when I see that pop, no.
I did this formula because I divided by 8 and I got back.
I probably should have paused the video. This would be exciting. Listen to all this background noise.
You can hear our arguments.
Yeah, maybe. All right. So there's the Ferris wheel. .908 in feet per second and pi over 900 radians per second, or 0.00349 radians per second. I mean, the thing's moving pretty slow, right? I mean, it's big, but geez, 30 minutes to go around once. So in a second, it's not going to go through a very big angle. Remember your string, the string, right? 1 radian, right, is like 57 degrees. I mean, that's quite a way. That's a sixth of the way around almost, right? Well, you're not, in a second, you're not going to go very far, okay? Matter of fact, what we found out here is about a foot per second, right? So you're going about this far every second. So that's not very, okay? So, but again, remember what we said? 1 revolution. As soon as you hear that, 1 revolution, that's 2 pi radians. So right away, I just put 2 pi radians over 30 minutes. But I needed it in seconds, so 1 minute is 60 seconds. So that's where that came from. And then V equals RW. So once I have the radians per second, all I got to do is multiply by the radius. 260, right? 520 diameter, 260 radius. And then the radians just disappears, and I get feet per second. Okay? So a lot like what we were just talking about there with those two. Angular velocity, once you have it, you just multiply. Okay, now. An arc 18 meters long on a circle of radius 8 subtends an angle of how many degrees? So that's S equals R theta, or some of you have also memorized theta equals S over R, but they come from the same thing. So S equals R theta, so I just put the arc length 18, the radius 8, units match, so that was good. So I just divide 9/4, 2.25 radians, and then you multiply that by 180 over pi. 2.25 radians, but remember the string. 1 radian, 2 radians, that's going to take you past 90, right? 1 radian was about 57 degrees, we said. So 2 radians should be over 100. So that makes sense. Number 2, and again, I think maybe we made that a little too difficult. You're right, the 300-year-old French, but 1 revolution, again, that's what you see. 1 revolution, okay, that's 2 pi radians. So 2 pi radians in 70 seconds. But they wanted it in minutes, and they wanted linear speed. But remember, we talked about linear speed, V equals RW. Just get the angular speed, then multiply by the radians. Get the angular speed, multiply by the radians. So 2 pi radians in 70 seconds, 60 seconds in a minute, so seconds cancel. So that's radians per minute, and then just so that's radians per minute, which is your angular velocity, your W, or omega, I should say, and then you multiply that by 7 feet. 7 feet radians. So that would be feet per minute, which is what they want. I mean, comments about that, or different way you did it, or where were you stuck on? I mean, somebody said number 2 they were stuck on. I don't remember who said that. Did you say that?
I think it was.
Do you remember where, or what was the sticking point?
Oh, well, Jeremiah reminded me of the 2 pi r for like, he wanted feet per minute.
Oh,
That's distance, I forgot about that.
right. So that's maybe, is that how you did that one? I mean, that's what the conversation we had today. If it says 1 revolution, so you're like, oh, okay, well, that's 1 circumference. So 2 pi r, so 2 pi times 7, right? So that'd be 14 pi, but then that would be feet in 70 seconds, and then you still have to convert it to minutes. So that would be a way to do it too, right?
Can you decrease the 7 and 6?
Sure. So you're saying, yeah, absolutely. Okay. All right. And then this last one. So we were talking about this. So this one was a little trickier because they gave you linear velocity. So usually that's what we're trying to find. Remember, linear velocity is like inches per second, feet per minute, miles per hour, something like that. So they gave you the 55 miles per hour for V. The problem is that's in miles and our radius is in inches. So we've got to get those distance units together. So the first thing I did was try to convert this, and they wanted the final answer in what? Radians per hour. Okay, so I went to feet. I guess I didn't go to inches. I went ahead and changed the 7 inches to feet. So 7 inches would be 7/12 of a foot. So I did that. But I could have done that right here. I could have canceled out feet and inches, right? So I could have said 1 foot down here is 12 inches. So I could have done that. Okay, but I went ahead and changed the radius to feet. Okay, and so miles per hour, I changed that to feet per hour. So I had 290,400 feet per hour. So I put that here. So remember, you have V equals RW. The V and the R need to be in the same units, right? If this is miles, you can't have inches here. Okay, so you do need those in the same units. Okay, and so that's why here I've got feet per hour, and then 7/12 would be feet. And then I just divide it. And then that's going to be radians per hour. Because remember, this is always radians. Those 2 formulas we talked about, S equals R theta and V equals RW, are always radians. Yeah. Okay. But that's a lot. I mean, think about it. You're going 55 miles an hour, and you're going to drive for an hour. You know, you're going to, how many radians, how many times, 2 pi every time around, you're driving for an hour. That's a lot of radians, right? I mean, that wheel's going to go around a lot of times in an hour. So you'd expect to get a great big number. Okay? But, again, it might have made more sense. It might have made more sense if I'd have finished this out. If I'd have went 55 miles per hour and then done 5,280 feet in 1 mile, and this is just getting my units to match, and then and then 1 foot is 12 inches. Okay, now feet cancel feet, miles cancel miles. And so it might have been better to get that instead of this number here, to get this number in inches per hour. Okay, somebody do that for me. What's 55 times 5,280 times 12?
3,484,800.
Okay, that would be inches per hour. So that would be my V. Okay, so I would have that, and then equals, and then my R would be 7, and then W, like that. Okay, so that might have been easier. Maybe that 7/12 is throwing you out there. But so when you got V equals RW, just keep in mind your linear speed and your radius, those have to have the same distance units. Okay, so this is miles per hour, that's going to be miles, or I change it to inches per hour so I could use inches here. Okay, so then you take that, divide it by 7, and that should give you that number right there. Okay, so maybe that made more sense. Okay, so yeah, so if they give you the speed that the thing's traveling, that's a linear speed. That's where you need the V equals R. Okay, all right, and then getting those units to match sometimes is the hardest thing. All right, so let's go ahead with the little bit of time we have left. You can start working on this. When we come back, we'll keep working on it. There's another one for your assignment. It's probably a little shorter. So there's kind of a couple worksheets here, but just the circled ones.
Oh yeah, the new update.
Okay? And I'll have an answer sheet up here that you can look at as you get working on a bunch of it if you want to double check and so forth. So if you want to work together, that's fine. But we'll pick right back up on this when you come back from lunch too. So.
Would it be fair to say that the formula that we probably need to know the most is V equals?
Yeah, I think so, because that's really the only thing that connects linear and angular velocity together. I think the other ones, the rest of it is about getting units to match, and then and to get angular velocity. I mean, to get angular velocity to start with, so you have something to multiply by the r. You just got to understand it's radians over time. And usually they give you revolutions, and just understand 1 revolution is 2 pi radians, right? I mean, that's where this one started, right? So 1 revolution in 70 seconds, so I started, and right there I was already at W, right? I was already at radians per second. And so then all I had to do is multiply by the R, and I had to get the units to match, so.
Over T times 60 seconds. So then you put 1/60th per second. Over, that's time.
No, it's okay. You can keep
20 seconds.
You gotta multiply it by 5 to get it.
Yeah. Oh wait, no, that's your linears. Okay, so then you're trying to
That's not right. When you multiply that by 5.
No, wait, that is angular velocity.
Okay, everybody, so this is another assignment that basically, this is a little more like the whole quiz, right? So this would be, it's got some of your radians to degrees, which quadrant, coterminal, that stuff, degrees, minutes, seconds, even on there a little bit, and then it's got some angular linear velocity. Okay, so that's kind of be good review as well. And I will post on the website under today's date, where I put the assignment, so Thursday, January 18th, I will post copies of the worksheets, and then I also have a copy of this answers for both worksheets. I have the answers worked out, right? So you can check it while you're reviewing and not have a bunch wrong and not know before the quiz, right? So I'll have that up there.
Isn't that just?
You just by times the radius.
Yeah. 1/60 times 5.